and welcome to this webinar. My name is Mark and I'm a Senior Solution Advisor with Insideworks. And today we're going to look at generating realistic production schedules for job shops and manufacturers, just like it says right there on the slide. This webinar should last about 30 to 45 minutes, depending on the types of questions you might have. If you do have any questions, feel free to enter them in the question box in the GoToWebinar panel there. If I don't get to those questions throughout the session today, we'll get back to you with answers via email through your registration after the session, but I'll do my best to answer them as we go. All right, with that, let's get started. So what we're going to do is just go through this little agenda here, a little bit about who we are, what MxAPS is, and then go through a software demo, and then kind of look at what it will, to some extent cost you to get into the solution. All right, so let's start with who we are. So Insideworks, we've been around for over a decade now, and we work primarily in manufacturing and warehousing, the manufacturing distribution area. And so we've got a lot of solutions in those various industries. We're based out here in Western Canada, but we do work globally. We've got thousands of customers globally. And the way we work is through our authorized partners. You can go to our website there and get a list of those partners. So if you have questions about the solutions, or if you want to get them implemented, those sorts of things, go find the appropriate partner for you. They'll be able to help you out, and we can get engaged with them to help determine what solutions out of this massive stack of stuff over here on the right that we have to offer. All right, but today what we're going to be talking about is MxAPS. So MxAPS, MX, by the way, the way that name came about, MX is manufacturing excellence and APS is advanced planning and scheduling. So MX is really what it says there. It's a finite capacity scheduling solution, and it has a lot of advanced capabilities to really properly model and schedule your environment. Right, so it allows you to get into a lot of detail to get the results that actually make sense when we send that out to the shop floor. So the goal of MX, you can sort of see a Gantt chart over here on the right-hand side, but the goal of MX is really to get rid of drag and drop scheduling or manual scheduling and things like that. Our goal is to turn scheduling into this fast, repeatable, and systemized process. Right, good production schedulers are hard to find. And, if they're taking 2 weeks off or whatever it is, that creates a real problem potentially in the facility. What you need is something where you can click a button and get a schedule out that you can reasonably execute out there on the shop floor. Okay, so how do we do that? Well, again, finite capacity forward scheduling. We do have, sort of backwards scheduling as well, but really what we want to do is schedule from whatever date you specify, whether that's the next shift or right now or whatever it is, forward schedule and tell you when you're going to be able to produce that product and all your products. And we take into account, all the equipment or stations, like it could be a welding station or it could be an automated machine or whatever. We take all of that into account, all those capacities into account, their loading, their preventative maintenance schedules, all those sorts of things can be taken into account to determine which machine should we use, which work center should we use when we schedule this work. And these alternates for special cases, like I'll talk about this more in the demo, but if we want to do subcontracting, the system can automatically select subcontracting as the best possible approach to generate the schedule that makes sense for you. And then, we've got configurable rules. I'll talk about that in the demo, and we can do it by production cell, all sorts of things we can do there. And this lot splitting is actually a very nice feature, because if you've got a large order, 10,000 pieces or something like that, that might take you a month to produce, you don't want to tie up one machine for that order for the whole month while everything sits and waits. We can split that up into multiple batches of 100 pieces each, or 5 individual batches or whatever, split that across machines or interleave that with other orders that need to get out the door. All right, some additional features. We're not done yet. So the ability to do a quick net change schedule. So you have a machine downtime, like a break fix scenario, where you go in there and something breaks, you mark that machine as down, and you can do a quick net change to reschedule everything around that machine to figure out what's the best approach to deal with that specific issue. This equipment maintenance scheduling, so the PM scheduling, if you have your PM orders in the system, we can actually go in there, and it's kind of neat, because traditional PM, you say, hey, Tuesday at 9 a.m., this machine is going down, you got to figure out how to deal with production while it's down. Well, with MX, what we can do is we can almost have a floating PM schedule. You say, hey, I got to get this PM done within this time frame, and it'll pick the best spot from a production perspective to put that maintenance order in to take that machine down. So you can kind of have a floating PM schedule where it's going to choose the optimal time to take that machine down. We can do things like non-production scheduling. Typically, this is some additional implementation work if you want to do this, but we do have customers that schedule their receiving and shipping through MX, right? They know when production is going to start, so they can actually schedule the receipt of their goods at, just-in-time receiving of those components, and they can schedule truck pickups because they know to a high degree of certainty, because MX tells them, when those trucks are going to be required to ship that product out the door. Okay. Setup reduction is another big one where we can go in there and we can reduce the amount of setup time that's required on your operations based on product type. So, you're using the same mold or the same tooling for multiple products. We can schedule those together so you don't have to do those changeovers, or we can sequence it from light to dark and then back down to light again, because going from light to dark is a lot less changeover than if I go from dark to light. And a whole bunch of other stuff. We can also constrain by, your components. We won't schedule an order if you don't have material for it. We won't schedule an order if you don't have the labor around to do that work, right? And tooling, I mentioned earlier, you've got a couple of things that need the same tooling. We're not going to schedule those orders at the same time because you won't be able to complete those production orders, even start them, if you don't have those constraints in place. So we can handle all of that kind of stuff as well. All right. Now, as far as where you can use this, pick a spot. We can, MX is being used in a ton of different areas. It's actually fairly large in automotive. Like if you drive, for example, a Honda passenger car in North America, it's likely gone through MX, or, you drive a Freightliner truck and, things like that. Those large organizations, billion-dollar companies are running MX to schedule their environments. But the way it's priced is that almost anybody can get into an MX solution. All right, anyway, we do a whole bunch of this stuff in, process and batch to some extent. We've got a few customers in there, but really pretty much any environment, we can usually tailor MX to match that just through configuration. Okay, now with that, let's jump in and see if the demo holds up to, all of these things I've been telling you it can do. So here we are in the UI here. And what I'm going to do is I'm going to just briefly show you what we're going to be manufacturing, and then we'll jump in and have a look at how that's actually scheduled. So step one, I'm just going to look at the items, the SKUs that we're actually producing. So I'm going to open that up. And what we're actually building today are these battery boxes and supports and things like that. So you notice we've got this AL, that's the aluminum, and we've got SS, which is stainless steel. Let me just grab this guy and show you kind of what it looks like, what we're actually manufacturing today, what we're trying to schedule. Oh, that's the backing plate. I don't want the backing plate. I want the actual battery box, stainless steel battery box here. Let's open that guy up and look at what we're actually producing here. So this battery box has got a number of levels in the BOM. Well, just kind of one level, but we do support multiple levels on the BOM. We've got one customer, they actually build turbines. They've got a 30-level BOM with, I think it's like 10,000 items on their BOM. We can schedule that stuff, and we can manage the constraints for missing components and things like that. But this is a fairly simple one, right? We've got a few subcomponents. We've got some labor associated with it. And you'll notice here, we're scheduling, for this laser cutter, we're scheduling it at a work center. So I have several laser cutters, and by scheduling it at a work center, it's going to choose the appropriate machine out of that work center to schedule that work on. The one below it, we've got this press brake here, and we're saying when we run this, this is our preferred machine. We always want to run it on this 90-ton guy. That's the guy we want to run it on. But as you'll see in the demo, if this guy is busy, we've got some options. Like if we can't schedule it on this for whatever reason, we've got some options to deal with that. Okay, so at any rate, this is what we're actually manufacturing, a bunch of these guys, stainless steel and aluminum. And then let me show you what we've got for the system in there. So we've got some production orders, some work orders to manufacture these products. And so we've got a whole bunch in here. I think I've got 50 some orders in here to produce. And some of these are subcomponents and some of them are the finished goods. But you'll notice the dates here. These all came in from the forecast. So because they came in from a weekly forecast, most of the dates are all the same day, right? We're expecting these things to all be completed the same day. Well, that's probably not realistic. We can't manufacture all this and have them all done on the same day and same time. That's just not going to work. But because it came from a forecast, it's just saying, hey, this is your forecasted date, or maybe this was a Friday afternoon and a bunch of salespeople entered a bunch of orders, and those guys aren't going to change the dates, and you're going to end up with garbage dates here. And by the way, this is all 2020 because that's the demo data that I have. But all of these guys are roughly the same date. Well, that's not going to result in a good schedule. That's not scheduled yet. This is just the date that the forecast said we need this stuff by. So what we're going to do with those orders, we're simply going to say, hey, I need to schedule all of that demand, whether it came from a forecast or sales orders or whatever, and I'm going to hit this generate production schedule. And in here, we've got a few options. Again, we can do it by production cell. So if you've got some cells that have very different rules and processes than others, we can schedule production cells independently, those sorts of things. And then I'm just going to say, let's schedule it from, April 12th at 8 a.m. is when I want to start my schedule. And I'm going to do a 30-day schedule. We can go out years. We can schedule years in advance if you want. This is really an executable plan right now. I want to see what's going to happen over the next 30 days. And typically you're going to run this, on a daily basis or every couple of days or even every shift. Like we've got one customer, very large customer, they do about $1 billion of parts every year. And that's way too much volume for anybody to manually have to do this kind of stuff. So what they have, the morning shift, the schedule pops out through an automated process, just pops out, goes to the shop floor. They work on that in the afternoon. Another schedule pops out for the afternoon shift that takes into account everything that was done in the morning shift, any break fix stuff, any of that sort of thing. And it's just all automated, okay? But if I want to do it, so I can automate that, or I can do it manually, say, hey, I want to schedule for this date and time, 30 days out, and I've got a bunch of other options here. I can set some filters, like if I only want to check my planned orders or my released orders or things like that. There's a whole bunch of things, but I'm just going to do this. And when I hit generate schedule, now, I've got 50 some orders in here. Usually that takes about 10 seconds to schedule, but it could be, in a real environment, well, that was actually more like 5 seconds. But in a real environment, if you've got a few hundred work orders out there, that might take a couple of minutes to schedule. If we've got 1,000 work orders, that's maybe 5 minutes to schedule or something like that. And what it's doing is it's telling me I've got a bit of a problem here because I've got 60 late orders on this based on the date I chose to schedule and all the other things in the system. Every one of the orders, I've got 60 orders to schedule. Every one of those suckers is going to be late. And if I go down, though, I can see a different schedule that I ran where I had some that were early, some that were late, the rest were on time. So you have the ability to do that. You can go in and it will tell you exactly what the quality of that schedule is, like, how many hours we actually have associated with executing that schedule, what's going to be early, what's going to be late, those types of things. And then I can make a decision. I can say, you know what, I don't want 60 late orders on this, and I can drill down, by the way, to see what's early, what's late. I don't want 60 late orders. I better add a second shift. Or what happens when I add a second shift? So I can go in there, mess with it, rerun the schedule, and compare, what's happening. Did I improve the schedule result, or did I make it worse? So you have that ability to do sort of what if scenarios. Now on this particular schedule result, I can drill down. By the way, this screen you're seeing here, let me just back up one screen. The screen you're seeing here is all the schedules I've run since the beginning of time or until I delete them or whatever we want. And again, this allows us to kind of do the what if planning. But if I open up the one I just ran, I get a lot of detail about that particular schedule. So I can go in here and I can see the detailed schedule for each individual work center, each individual operation, each individual lot within that operation, those sorts of things. So this gives me, this is basically the dispatch list. So I could come in here if I wanted to produce a dispatch list for this, well booth 1, I can quickly filter. There's my dispatch list, my order list for well booth 1, sorted by, the start date and time. And a lot of people will use this. They'll publish it out on the shop floor, those types of things. This is not something I would use as a scheduler unless I'm trying to track down what's going on. Like if something went wrong in the schedule, this order is late, and I want to figure out why, I can drill down and figure that out. But really, what we want to do after we generate the schedule, at most, ideally, is just do a once over, look at it graphically and see, hey, does this schedule actually make sense or not? Like, do I see lots of big gaps or what's the issue with this thing? So what I did there was I just said graph results, and that opens up, the graphical schedule, the Gantt chart, and shows me exactly what was scheduled. And here's a good one to start with. This laser cutter here, this is the work center. So within that laser work center, I've got these two machines. And if you remember back to the routing that I had up, when we define the process to produce this part, I just put everything, I said, hey, it needs some laser cutting. Well, MX went and figured out which machine would be best to use to actually do that work. Okay, so it chose the appropriate machine. By the way, the colors here, you can set whatever you like. If you go into the view options here, you can come in and you can change colors. You can add information on here, like if you want to put the sales order dates and things like that on this chart. You can do all of that kind of stuff. But the colors that I have here, this magenta is our setup time, and the green is our run time. So we can see how much time is required for setup and how much time is required for run. And again, we can eliminate that setup time if we've got that set up. If I'm running the same part multiple times or similar parts, I can do a partial setup reduction or a complete setup reduction. So for example, if I've got, I've got a die that I'm using or a mold is better. I've got a mold that I'm using and a different color. Well, I can have two setup segments for that, one for color, one for mold. And I can set it up so that I use that same mold for 10 different colors, and I only deal with the color changeover until I need to run a new part, and then I do the mold changeover as well. So I can reduce the setup at multiple stages. All right, anyway, back to the laser cutter here. So the laser cutter, after I do the laser cutter, what it does is it goes off and it runs that work on the preferred machine. So this is a long bracket. This guy here, you can see the word long there. By the way, you can control what text is showing on this, pop-up and what's shown in the cell. But this long bracket, our preferred machine is this 10-foot, 90-ton press brake. And so every time it runs a long bracket, it's going to try and schedule it on that machine. But there may come a time where this machine is too busy to schedule one of those things on it. And let's see if this schedules. So here's an example here. On this one, this is a long bracket. But if we go down here, this machine was too busy to run it at that point in time. It couldn't run that on that machine here. So what it did was it chose an alternate machine to use. This machine is slower, it's maybe more expensive. Whatever criteria you want to put on there, that may have a big impact on why we don't want to use this machine. But the system said, you know what? In this case, in order to produce the best schedule based on your rules, you should run it on this machine here, taking into account the extra time, the extra cost, everything else. Now, the nice thing about that, this is an internal machine, one we run in the shop, but this could have just as easily been a subcontractor. So we can make intelligent decisions about when you should subcontract, when you should do it in-house, what machines you should run it on, and that's all automatic once you've got that initial setup done. Okay. All right, so that's the laser cutting and choosing the alternate machines and everything else. If we go down here, speaking of subcontracting, this guy here is, this powder coat is a subcontract. And you'll notice I've got two orders scheduled at the same time because we don't care about the subcontractor's capacity. We're just sending him this stuff out. He's saying it's going to take a week to do, and out it goes. And we could load up 20 orders on this machine here because it's a subcontract machine. We're not managing the capacity of that. But this could also have been an internal machine. Maybe we go in there and we say, hey, what are our bottlenecks in our process? And today, if you want to figure out what a bottleneck is in your manufacturing process, that might be a little bit difficult. You go out there and wander around the shop floor and see what's slowing things down with the stopwatch and all that kind of stuff. Well, MX, when we run the schedule, it can tell you what your bottlenecks are. We look for machines that have high utilization and have high queue time, right? Have a lot of WIP piled up in front of them, but they're in high use. That tells us it's a bottleneck. And then you can say, well, what if it wasn't a bottleneck? What if I make that an infinite capacity machine? What's that going to look like to get my best schedule if that machine didn't have a bottleneck? And you can use that to sort of analyze what you need to do in your environment to figure out how to improve your scheduling or how to improve your throughput, more importantly, right? In this case, it means, hey, I need two of these machines, or maybe this is just labor. I need two people on this instead of one person, depending on what that machine requires, okay? So it allows you to figure out what your bottlenecks are and come up with ways of identifying how to correct those bottlenecks, or just do subcontracting like this guy is. Now, another one here on this welding booth, just for fun, let's look at this guy. So in the welding booth, you know, same thing. We've got the schedule. We've got 2 welding booths here, and that work is scheduled, you know, fills up that machine for the capacity that we have. But if we scroll over here, you'll notice that at 4 p.m., it stops scheduling 2 production orders, 2 work orders on welding. And the reason for that is at 4 p.m., we go to the night shift and we lose one of our welders. We only have 1 welder on afternoons. And now you can see we're only scheduling 1 production order at a time on that specific work center. So that's an example of how we can constrain the schedule based on labor. We can use fractional labor. We can do, you know, individual employees. We can also do, again, material. Maybe one of these production orders didn't have the material required to start that operation. Well, we'll push that out into the future, and we won't schedule that until that material is available, either based on incoming purchase orders or on lead times that you specify on the SKU, or a global lead time. You can say, yeah, anything I need, I can get within 2 weeks. If that's your global lead time, you know, we'll push it out for 2 weeks, knowing you'll have the material in time to start that work, all right? And tooling and everything else that I mentioned. So really, that just, you know, this view shows you, illustrates some of the things that the system can do. You know, choose the alternate work centers, choose the best work center to do the work on, constrained by labor, material, tooling, all of those sorts of things. But ideally, you know, you never have to look at this. You never have to use this as a validation tool, because if you've got your model, you know, you set up your capacities and everything properly, you run the schedule, you're going to send that out to the shop floor. They're going to be able to execute to that schedule, and you won't have to deal with it. Now, if something goes wrong, or if you do want to deal with it, you say, you know, this is a bad idea. This is junk. This needs to run on a completely different machine. I can actually take that and I can drag and drop that guy around and stick it wherever I like. And when I rerun the schedule, do a net change, it will take that movement into account and schedule the other production orders around it, taking into account my preferences. Okay, so I can do drag and drop on this. If you really want to go back to sort of manual scheduling, you can. But our goal is to save you from having to do any of this stuff, other than review it and go, hey, that looks pretty, I'm going to do that. And when we're ready to do it, we simply go in and we commit it, and then that makes it the active schedule that the people in the shop can work towards. So that's how the system works. So I hit generate schedule. I optionally come in, you know, look at the, just didn't click that, you know, look at the results real quickly graphically. When I'm happy, I commit it, and that's my entire process for the day. Or if you like, you just automate it, and every day you've got a schedule that the shop can execute. All right, now let's talk a little bit about how we set that guy up. So the first thing I'm going to do is I'm going to go into, well, you know what, actually I'm going to go into the setup for a second here. So we're going to go into the general setup page. I'll just talk about a couple little things here. Number one is the priority. I didn't talk about that yet, but we can set priorities on orders as well. So I'll show you the scheduling rules, but this is the first thing we look at, is what's the priority of that order. So if you've got a rush order or something like that, or a customer phones up and complains, you can flag that order as a higher priority, and it'll get the first attention in the schedule. So you can bump orders up in priority, or you can have customers with a standing priority that always gets them, you know, their stuff out first, or you're running a campaign or whatever. Anyway, we can set it by priority. And there's a bunch of stuff. And then the other thing that I wanted to mention is what happens after we generate that schedule. So I mentioned automation. We can go ahead and basically have this run automatically. So it says here, if you want to do it in the job queue, which is the scheduler, you want to run it in the scheduler, we set this up to automatically run that and commit the schedule, and you never have to touch it. It just runs overnight or every hour or whatever it is, pushes it out to the shop, and we're good to go. So this is very little setup. You run the setup wizard, it puts all of the stuff in by default, and we're effectively good to go. Next step is we actually set up our routings. I won't get into, you know, setting up the work centers and machine centers. That's pretty basic. But let's go in and have a look at how the routings are set up to do this. So I'm going to go into, you know, let's do this bracket here. I think this is one that's got some stuff on it. Yeah, this is a good one. So this is one where, you know, we've got this this routing to produce this product. So we've got some laser cutting, and this is where we want to run this guy on this 10-foot press brake, right? That's our preferred machine. And you saw on the graphical scheduler there where it didn't run it. In one case, it didn't run it, ran it on a completely different thing. So first of all, we've got all sort of the basic stuff. We set up our setup time, our run time, and whatever unit of measure you want to use. And then when we come over here, we've got some more advanced configuration that we can set. So we can also indicate which production cell we need to perform that activity in. And here, this alternate, this is where we get to define, you know, what options there are if we can't schedule this work on this particular machine. What are our options? And we call those alternates. If we open that up, so I'm just going to come in here, and I have a couple, like I have one for laser and one for the press brakes. And if I open this guy up here, we'll see what our alternates are. So the first thing we've got, our first alternate that we can look at is that 120 ton, which is what it actually chose. And the other one is subcontracting. So what the system does is it looks at every possible scenario. It says, hey, what happens if I schedule it on the, you know, preferred machine? Oh, that looks pretty bad. Or maybe it doesn't say it looks pretty bad, but it schedules on that, looks at what the result is. Then it looks at all these alternates and says, well, you know what? If I schedule on this, I get a much better result. And if I schedule on this, maybe I get an even better result. And it'll choose the best result out of all the possibilities that you provided. So it goes through and looks at every possible option and chooses the best one. And in this case, the subcontracting, this sort of nomenclature or format here indicates it's going to take 48 hours. It's going to add 48 hours onto you know, our production time. And so for, you know, the stuff that takes a day or two to manufacture, it's never going to choose that. But this one, it takes twice as long to do it if we do it on this guy here, but it still chose it, even though it takes twice as long to do, because the other machine was just too overloaded. Okay, so this is the machine alternates. And again, it's very intelligent in how it does it. It looks at every possibility and chooses the best solution out of all those possibilities. Okay, and a couple of other things, you know, we get into a great deal of detail on how we can actually model your process. Like for example, this allow breaks. This tells us, can we stop working on something when there's a shift break or a weekend or something like that? And in the case of welding or whatever, sure, I could just, you know, put it down, go for a break and come back later and finish up. But if you're baking something, or if it's in a, you know, an oven for heat treating or something like that, you can't just, you know, turn off the oven and then come back 2 days later and turn it on again. That doesn't work. So we can prevent an operation from breaking over shift breaks and things like that. I'm not going to go through every option here because there's a ton, but I'll mention a few, like just in time. We can do just in time scheduling. So it's kind of like backwards scheduling, but we can set it up for just in time. This max early and max late, those are handy if you've got products that expire, right? Because the goal of MX is to say, you know what, I want to get this, I want to get maximum throughput, which means I want to get this stuff done as soon as I possibly can. Well, maybe your customer doesn't want this stuff shipped out until the end of the month, and I can finish it next week. Well, by the time I ship it out, maybe it's halfway through its expiry date or expiry period. So you can set it up to say, you know what, I don't ever want to finish production on this, you know, if it's more than 2 days early. And that way, I'm not going to ship half expired product out to the customer when they've ordered it ahead of time. Or, you know, maximum days late. I can say, you know, I can never allow this to be more than 2 days late. And this is yelling at me because I have this as certified. So engineering or whoever would have to release this. Well, routing is probably the production guys, but they'd have to mark this as under development in order to make changes. That's why I'm getting this message here. But anyway, I come back in here, and this maximum days late is kind of nice because I can say, you know what, I never want to run this thing late. If I put a maximum in there, it just won't schedule. It'll show up as one of the orders that it can't schedule because there's no way it can figure out to make it work without making it 2 days late. And then you've got a nice exception report you can go in and look at and say, hey, this order didn't schedule. Why didn't? Oh, I don't have material, or I didn't have labor, or whatever. And you can figure out what to do about that and address it. Okay. A few other things here. I'm not going to get into all of this kind of stuff. The secondary constraints, that's what when we talk about labor and tooling and all those sorts of things, we can enable or disable those types of things. And then the lock transfer stuff is actually a very useful capability because, again, if you're building, 10,000, whatever they are, brackets in this case, and, that's going to take me a month to do, again, I don't want to tie up a machine for a month to do that order. I want to break that up into maybe, I can say, yeah, I want to be able to schedule that across up to 5 machines. And it'll take whatever quantity on that order and break it up into 5 different lots for different machines. Or I can say, you know what, every time I get an order for this, I never want to produce more than 1,000 of them in one shot. And what that'll do is it might break that order up into 10 different lots and schedule it across 10 different machines. Or depending on priorities and things like that, it might interleave other orders. Like it might do 1,000 of these and then 50 of a different one and then another 1,000 of these, those types of things. So it's very intelligent in how it can break up large orders as well. Okay. So a whole bunch of other stuff here that we can do. And I'm not going to get into it too much. There's a bunch of stuff for setup minimization and all those sorts of things. The point of this is we can do, very comprehensive modeling of that production. And one thing I forgot to mention, I'm going to show you in a sec. You can have as many of these user attributes as you like as well, primarily for sequencing. So on one of these guys, I can't actually even remember which one. Yeah, it's these guys here. So if I open up one of these guys, we'll actually see it. I've got some welding to do. And you can see I flagged this one as stainless steel. That's this SS. So this one's flagged as stainless steel. The other guy is flagged as aluminum. So I've got these user attributes I can assign here. And what that does, I'm just going to go back into the schedule view here just for fun. Well, more than fun. It's, oops. And of course I clicked the wrong, that's good enough. This is a slightly different one that I ran before. I'm viewing the active schedule. I'm not viewing the one I just ran, but it's got the same concept. So what we see here down in welding, if you look at this, I can't move my mouse over there, but this is an aluminum one. If you look at the item, it says AL at the end there, that's aluminum. This is aluminum. This one is aluminum. And now we've got stainless steel and stainless steel. So what we've done is we've actually sequenced this based on that user thing, which is, in my case, material type, but quite often that's going to be color, right? So I'm running all my aluminum first, then I'm running all my stainless steel, and then I'm switching back to aluminum. But we can do that with color, with heat treating, with whatever you want, where we can sequence those orders based on whatever attributes you specify. So let me show you how we set that up. So the way we do that is through our scheduling rules, which is the next thing to look at. So a scheduling rule, you can have as many as you like, and you can have different scheduling rules for different production cells. So again, you might have, an assembly area and an injection molding area, or an assembly area and a machine shop area or something like that. They run differently. You want to sequence the material differently or schedule differently, you can set that up. But in mine, I've only got one rule. And this is sort of the default rule that we set up when you install the system. And what it does is this is the order that it looks at the attributes to schedule. So number one, it looks at priority. So priority overrides everything else. It looks at priority. Higher priority orders are always going to be scheduled first, regardless of anything else that we want to look at. So if all the priorities are the same, the next thing it looks at is due date. So it's always going to try and schedule, the orders that need to ship first are going to be scheduled first. And then here's that user two. That's my material type. So I'm going to first look at priority, due date, and then I'm going to sequence by material type, and then by order number and order attribute key and a whole bunch of stuff. So there's a million things, well, maybe not a million, but several dozen things you can use to define your scheduling rules. Like some of these are very esoteric, like critical ratio and things like that, but maybe you want to schedule based on cycle time remaining. In other words, the orders that are closest to being finished get the highest priority. That maybe you want to do that, right? Smallest orders first, or whatever it is. Or the days, the orders that are most overdue are the ones you want to look at first, those types of things. So you can set up all of these, and again, you've got a ton of these user fields you can set up to basically sequence on anything you like. And in addition to that, let's say this user two is color, what I can do is I can set up how we actually sequence that. So in my case, I just do ascending, right? So I go, let's say it was color, I go light to dark, and then I start again at light. But I can do descending or sawtooth waves. So again, the sawtooth, we start at the lowest value, we work up to the highest value, and then we drop down to the lowest value. Or these triangles. And a triangle, you picture it, I'm starting from a small value, moving up to a high value, and then moving back to a low value. So that's great if you're doing baking or heat treating or whatever, you're using an oven or a kiln or something like that. You start at the low temperature, so we sequence all the stuff that has to run at the lower temperatures, and then we increase the temperatures and then slowly decrease the temperatures back down. So anyway, lots of things you can do there, but the vast majority of the people, this type of rule, the one that gets installed by default, works just fine. But very easy to configure different rules for different situations, different material types, different attributes, whatever you like. Okay, so that's, in a nutshell, what MX will do for you. But one thing that's quite important is every time we generate that schedule, it's going to look at the current situation. It's going to say, these are the orders I need to schedule. But what we also need to know is, what have we completed on that order so far? If I'm supposed to produce 1,000 items, or if I've got 30 hours of labor required for a specific order, how do I know what's being completed so that, if I've got 25 hours done on a 30-hour order, I don't want to schedule 30 hours again. I want to schedule the remaining 5 hours. Or if it finished 50% of the production by piece count on an order, I only want to schedule 50% of what's remaining. So how do we do that? Well, you can go in and manually type in your production order statuses, right? Like, what did you actually complete on the shop floor? How much labor went into it? But there is another option as well, and that's using Shop Floor Insight. So Shop Floor Insight is a bit of a companion tool to MxAPS. You can use it with it or without it, but really what this allows us to do is capture information from the shop floor that will feed back into the schedule. So we close that loop, right? We run the schedule, it tells us what we should be able to execute, we send it to the shop floor, and people on the shop floor just scan barcodes or use touch screens to record what they've actually done. So for me, there's lots of ways you can set it up. We do have an online video that shows you how this works. But for me, I'm just going to quickly clock in as myself. So I'm tracking time against my specific employee ID, but we could just do it for the Welding Work Center if you like. And then all I do is I simply scan, if you've got a traveler out there, I'm simply going to scan what I'm working on, what activity I'm doing, and that's it. It's like the old Roadrunner cartoons. I go beep, beep, and I run off and I do my work. Or if you want to use a touch screen without a traveler out there, you can do that as well. I won't get into the details of how that works, but it's pretty simple. You can use touch screen, you can use barcodes, and this is feeding that back into MX in real time. I know exactly who started this, how much time has elapsed on this, what they've completed for production. All of those sorts of things will get fed back into MX so that the next time I schedule, I've got an accurate schedule based on what's actually being completed in the shop floor. Okay, so it's very important that we're able to get that feedback from the shop floor so that your schedules are realistic. And one other quick note on that, when we do that, when we have, realistic labor times coming in from the shop floor, it allows you to do some analysis like, are my expected run times accurate? Like, am I actually scheduling things appropriately? Maybe I've set something up that says, oh, it takes 2 hours to run, but in reality, it's taking 3 hours, and I'm wondering why we're never, meeting our schedule. Well, it's because my routing's wrong, my expected time's wrong. So we have this tool for routing analysis. It allows me to go in there and select, a product that I'm producing, and I'm just going to leave all of these things wide open. So I'm just choosing that routing. And what it does is it tells me, okay, this is the number of orders I've run with that particular routing. So 2 isn't a good sample size. But, I ideally have a whole bunch of these. And this is telling me how closely I'm adhering to my expected time. So this is the time I expect it to take when I produce this product. And this is my average actual time it took me to produce that product. So I've messed with this, I've changed this. Usually these are much bigger differences. These are all pretty good, right? Like I'm pretty close. Well, this I'm 43% out, and this one I'm 71% out, but actual time I'm not bad. But what this allows me to do is very quickly say, yeah, oh geez, I'm 70% out. This is only taking me, this is in hours, but you can have it set up in minutes, days, whatever you like. And I can come in and go, yeah, you know what, I'm going to change that right here. And that's actually should be this, and it will come in and change my expected times now. So the next time I run a schedule for this, it's going to be much closer to what it actually takes to do out in the shop floor. This guy here is an interesting one because I'm within 5% of my expected time. That's not bad. However, I have a big problem here. This is my variability in that process, the standard deviation on that particular process. So what that's telling me, that's like 8 sigmas out. Every time I do this, it's taking me a different amount of time to do it. That's bad. You want repeatability in your process. You don't want when Fred does it, it takes 5 minutes, and when Joe does it, it takes 2 hours. You don't want that. You want this consistent. So this tool gives you the ability to both monitor, an absolute time difference and percentage difference, and also how much variability you actually have in your process. And this is extremely important to be able to schedule properly. If you don't know how long things are actually going to take or how long things need to take in the shop, you're never going to be able to produce an accurate schedule. So the main thing is MX will produce that schedule for you and models things very well. It can deal with pretty much anything you throw at it. And then we close the loop by getting that real-time feedback from the shop floor, or at least, we need that feedback from the shop floor. And then you can do some analysis to determine, are your schedules actually going to be accurate based on the time it really takes in the shop. Okay, so that's all I wanted to cover today. It looks like I probably answered most of the questions that have come in. But again, if there are questions that you've asked that I haven't covered off during the presentation, we will get to those via the email afterward. All right, now, after all that, you're like, wow, that's pretty neat. I kind of like that, but what's the bottom line on it? Well, again, MX has been around for a long time, and we've got a lot of customers that have done a lot of studies and everything else on it, and these are actually real results we've seen from a number of customers. So significant increase in throughput. I mean, that's just a no-brainer. It's going to give you an accurate schedule that you can execute on the shop floor, and you're not going to have the problem. I forgot to rant about this in the middle of the demo, but what we see quite often is, if I walk into a shop and I see a lot of WIP out there, you've likely got a scheduling problem, or you're just really busy. But what ends up happening, if you don't have a tool like this, you get a lot of local optimization, right? Somebody comes in and they're supposed to, do a specific, work order. They're supposed to work on something, but it's not quite ready yet from the other, work center. So they grab something else to work on. They're like, oh, I'll just keep busy. I'll grab this other thing to work on and keep going. And that ends up being a big mess, because now, the downstream from that is going to be waiting for things, and things are going to get done out of order, and you end up with a ton of WIP sitting around on the shop floor. If you have a schedule like what MX produces and says, this is the order you need to do things in, and it's accurate and realistic, you're going to get massive increases in throughput. Okay, and with that, reduce that labor, because people aren't going to be running around looking for pallets of WIP or figuring out what the heck's going on. It's just straightforward. This is the list of things you need to do in that order, and things get done. Okay, and all these other things, you've probably read all of this stuff while I've been babbling, but a ton of things a ton of benefits you get out of that scheduling. Even overtime reduction, all of those sorts of things come into play when you have a good schedule. All right, now with all that, what's it going to cost you? Well, there's obviously some user licensing to get into the system. Run MRP, run the scheduling, do the routing analysis. Shop Floor Insight has some licensing, but MX specifically for the scheduling, the way we price that is based on the number of production orders that you're scheduling. So if you have, 200 active orders in the shop, you're going to have to get the license for 200 orders. And it's a fairly low cost license. Again, talk to one of our authorized partners. You go to our website, look those guys up. They can give you pricing on the full solution, including user pricing, scheduling pricing, everything else as well. All right. With that, if you need more information, go to manufacturing or mfgscheduling.com. There's videos, like more detailed videos on a lot of the concepts that I talked about here at a high level, articles, all sorts of good stuff. And again, you can go ahead and look up an authorized partner to use to get a more formal quote, anything like that. You can go to our YouTube channel. There's a ton of videos there for a number of the other things I mentioned as well, like Shop Floor Insight. One thing I should mention, when you leave, there will be a survey that pops up. Please fill that in. It's very useful for us to get some information on how we're doing. With that, would like to thank everybody for attending, and I hope you have a great rest of the week. Thanks, everyone.
Hey, thanks for watching. I hope you enjoyed this video. If you haven't already, make sure you subscribe to our YouTube channel for more great content.